Hi! So today I wanted to show you how you can create a game with the mechanics of Flappy Bird within the Godot game engine. So you can see on screen right now the mechanics here are quite similar. Now I am doing this in a 1920 by 1080 format, but you can just adjust the numbers a bit if you want to make this for, let's say, a mobile game or something and want to change it a bit. So let's see. To start out with, I am adding a canvas layer, which I'll just be using for the background. You don't necessarily need a canvas layer for this, but it does make it a bit cleaner in case you later want to work with scrolling backgrounds or something of the sort. So let's take a color rect, give it the proper size 1920 by 1080, so it covers the entire screen. This will be our sky color, so let's make it something like this. Then we can duplicate this and just call this sky and this grass. So make this one green, maybe not too green. And change the rect a bit. Let's see, size, let's make it 100. And put it at position 1080 minus 100. And that should be fine. Now next, let's create a player. I'm just making the player on area 2D. We don't really need the physics system for this. I'll just be doing the calculations by hand. They are quite simple. Collision shape 2D. Alright. Let's move that somewhere here. The player needs to be visible, so let's give him a Godot head. 0, 0. Let's make it yellowish. Yeah, something like that. That looks a bit more bird-like. I suppose we could also scale it or something, but I'll leave it for now. Right, now that we have a player, let's also call it that. And give it a script. So what do we actually need for our player? Let's see. Export var g for gravity equals, I don't know, some big number. Export var flap speed, let's say, equals some other big number. I'll figure out the exact numbers later. For now, let's just put something. Then let's say var started is equal to false by default. That way we can react to the first button input to start the game. And then of course we need a y velocity, which starts at 0. And a kind of fake x velocity, because we don't actually move on the x-axis, but we still want to know how fast the background is scrolling behind us. So I'll keep that around. Now we don't actually need a ready function in here. So let's just start with physics process. What are we actually doing here? If it's already started, we can do stuff. If not, we just skip all processing and stay in place. So then we can say our y velocity is plus equals g times delta. Because gravity should be scaled by delta. And then if input is action just pressed flap. I just defined a flap action for this in the project settings. Let's see, input map flap. I put it on the spacebar, put it on whatever you want. So if that is pressed, y velocity is set to minus flap speed. I'm putting a minus here because the y-axis is inverted. Like the positive direction goes downwards, we want to go upwards, but it's still more convenient to have a positive number when trying to set this value. Now we have pretty much our gravity calculation done already. So let's say position.y plus equals y velocity times delta. We are not actually changing our x position ever. Additionally, let us update our rotation. So what we can do is say rotation is equal to vector 2 x velocity, y velocity, and that's what we're keeping the x velocity around for, even though we're not moving, dot angle, vector 2. So essentially, this vector here is pointing in whatever direction our bird is moving, or in this case, our Godot head, and this angle is going to tell us what our rotation should be if we're trying to face this direction. So if we're moving up, it's going to point up a bit. If we're moving down, it's going to point down. You'll see that in a moment, but first we need to be able to start the game. Let's add a script here. And for starters, let's just say physics process. And this one should also be aware if it started. So let's say started equals false. If not started, and if input.isAction just pressed flap, started is true. So that's how we can actually start the game. Additionally, we want to start the game for the bird. So what we can just do is we know what our children are. So let's say var burp equals $player. Alright, it's an onReady node, onReady var player. There we go. So then we can say burp.started is also equal to true. And that's really all we need at this point. Let's take a look. Ah, no, never mind. That's almost all. This one here actually needs a ready function. Func ready. So what we need here is we need to say burp.x velocity is equal to the scroll speed from here. The reason for that is the scroll speed really has nothing specifically to do with the player. So we should be setting it in this place here instead. So we can just say export var scroll speed equals 600 or something. And take a look. Okay, our gravity and flap values are not very good, but you can already see that the movement is working. It's going up and down just fine in a Flappy Bird style movement. So let's improve these values a bit. Let's say 3000 and 1200. That's a lot better, yeah. Yeah, I might keep that for now. So with that working, it's time to start implementing some obstacles. So here in the game, I'll just say add another node 2D, and this is gonna be our segments, I guess. And yeah, let's start by designing one of these segments. Okay, what do we actually want in here though? Let's see. Let's make a node 2D parent. And then it can have... Actually, yeah, let's take some Godot icons up in here. Make them dark green-ish. Now, what's gonna be the scale of these? Y scale of 10, let's say, an X scale of 3, and that should be roughly a decent size. Put it about here, and that is not correct. Oh, it is. Actually, the grass is in the wrong place. Why is that in the wrong place? 1080 minus 100? Okay, yeah, now it's aligned properly. I must have made a typo there. So yeah, I thought I had the right numbers. Okay, let's see. So I want a second one. Let's move that up to, well, same x coordinate, but minus 320. Now, I mostly got these numbers by trial and error. I just moved stuff around a bit and looked at which numbers looked fine. And what this essentially means is this empty space here at the start is also going to be empty afterwards before the next one comes. So the real size of one of these segments is really this entire height and this entire width. That's why I'm moving it off to the side like that. You can use different values, it just means you're gonna have to make some changes in the code also, since that is going to be putting these next to each other at always the same distance. Right, now that is this part done. Let's add some collision shapes, area to these. Rectangle shape. Okay, let's see, what exactly do we want for this? Make it 96 here, 320 here. Position it at 576 and minus 320. Alright, make a second collider. Keep the x coordinate, move it to 760. So these are gonna be in the same locations as these sprites. That's fine for now. Let's save that as a separate scene, so we can use it later. Now we're gonna want some script to be able to move these things and spawn them to begin with. So what we can do is, let's start with spawn inst with an x location, var inst equals, and we're gonna need a scene for this. We just created one, so let's use that. Var obstacle Scene equals preload segment.tscn. That should be fine. That thing.instance is what we want here. Then we position it at location vector 2 x, and now we need to randomize where this thing can actually go. So let's say we want to keep a minimum distance of 100 at both the top and the bottom, so they always poke out a bit. So we can say 100 plus random integer mod, and let's see, we want 640, which is the maximum possible thing due to the height of our segments. But we want a 100 offset at the top and bottom, so minus 200. And that should position them fine. And we can say segments.add child inst. And that's how we can just spawn in an instance by the x coordinate. Now, how are we going to move these things? Let's see, there's a few things we're going to want here in the physics process, I think. If it's not started yet, no, if it is started, we want to go through all the areas or segments in our segments, get children, and update their position. So area.position.x minus equals scroll speed times delta. If the position is too far left, so the stuff has gone off screen, if area.position.x is less than minus 672 it was. That was the width, I believe, minus 672. Then we can spawn in a new instance at area.position.x plus 672 times, I guess 4 will do, just to make sure we always have enough to cover the entire screen, and area.q3. So with this, whenever one goes off screen and gets removed, a new one is spawned in as well. And of course I need to close the brackets. So this should get moved fine, but we're not spawning in any at the start yet. So when we are pressing this flap button for the first time ever, let's spawn in some of these. So one at 1920, so that's one starting barely off screen. Then one at 1920 plus the width of one of these things, so 672. Then one at 1920 plus 672 times 2. So we have 3 of these, and let's spawn a 4th one at 1920 plus 672 times 3. So now we should never run out of obstacles. Let's see what's happening so far. Oh, it's spawning too many, isn't it? That's because I didn't remove the first one, I think. So let's remove that. We have it as a scene anyway. Looking good. There isn't actually any collision yet. So right now I could just fly through these. But we'll take care of collision in a moment. Now, before we take care of collisions, let's actually add another canvas layer. So we can start counting scores. Let's create just a label in there. And let's zoom in on the canvas layer a bit so we can see properly. So let's make it like 6 times its size. No, not layer. Size. That's here. 6 times, 6 times. Scale up the entire canvas layer. So we have a label that's actually readable. Even that is actually not that big. Maybe make it 10 times? Yeah, that seems fine. Make this centered. Top is fine. Move it about here. And that gives us something that's always going to be in front of everything and still visible. So how are we going to update our score? First of all, we need to change our segments a bit. Because right now we only have this here for the collider, which actually doesn't need to be monitoring. You could just keep it unmonitorable. But we still need a second area to D in here. This is to check for score. Let's just call it score area. Very creative. Collision shape 2D. Give it a rectangle shape, I guess. And this doesn't need to be awfully precise, I guess, but it should be in between these roughly. And we're moving this to a different layer. So if we click here, collision layer, this will go on layer 2. That way, if anything ever collides that shouldn't, we don't have to worry about it. Now on the player is actually getting a second area to D as well. Because that way I don't have to check specifically what type of object I'm colliding with, I can just check what layer I'm on. So this basically just needs to be monitoring, because nothing is ever going to be seeing the player anyway. And this is on layer 2, so it should be able to see the others. Add another collision shape. Make this a rectangle. And yeah, it doesn't really matter. It's somewhere in the player, and that's fine. That's all we need. Now, what are we gonna do? Whenever this thing gets hit, let's say, whenever area entered, on the player of course, we are going to want to emit a signal for this. Now, I've already created an autoload script for these signals. Let's take a look. So this global script here, I just call it global, has two signals, one for point gained and one to reset points later. So yeah, that's pretty much all you have to write here. And then you can put it into the auto load thing here. Just click on the path, select it, and you're good. I already have it in here and it's enabled. So that's all we need. So how are we gonna use this? We can go into the player, and whenever this here happens, we can just say global.emit signal point gained, because we just touched one of these score areas. Take a look and see, yes, this label here still needs a script, of course, to actually update itself. So now what this can do is it can connect itself to that signal we just emitted. So say func on point gained, and then we can just create another one while we're at it, func on point score reset, points reset. I forgot what it was called. Anyway, we have them here. Global.connect point gained to self, because that's where we are. We are not going on anything else. On point gained. Easy. While we're at it, global.connect reset points, that's what it was called. Self on points reset. So now these two functions are connected to the signals and will be called as soon as these things happen. This thing has a score starting at 0. In the case that a point is gained, we can just say score plus equals 1 and text equals string of score. And if we're resetting, we can just say score equals 0 and text equals string of score once again. This is looking fine. If I go down here where I don't touch them, the score doesn't update, but it updates fine whenever I'm actually in the range of this area. So this is how we're gonna gain points. So now the last thing left is we actually want to be able to die. So, player. The player needs to recognize when it's dying. And for that we can use the area2d, that's the player node itself. And just say area entered once again. Connect it to ourselves. And in this case, whenever this is triggered, burp dead. So what can we do here? We can say started is false, because we want to reset our position. And we can reset our position to the starting position by just saying here var start pos equals position. Let's make that on already. And then here we can just set our position back to start pos. Besides that, we will want our rotation to be 0 and our y velocity to be 0. And I think that's pretty much it. Now, one issue here is that our parent, the game node, doesn't actually know the player died yet. So to be able to do that, let's just add a signal to the player. We could technically just call a function or something in our parent, but for decoupling and stuff, it's actually a bad idea to do that. It makes it difficult to move things around later when there are function calls in both directions all over the place. So instead, we usually just say the parent knows where its children are, but the children don't know where the parent is. So let's say signal burp died, and we can emit that signal here. And then we need to catch the signal in the parent. So in the ready function, we can say burp.connect. It's already showing up here, so let's take that to self. And we need some function for this on burp died. on burp died. So what should happen in the player in this case? Started should be false, so everything stops moving again. And we want to get rid of all the areas we spawned in. So for area in segments.getChildren area.queue free. Let's try it. So let's get some point. Let's die. And we're set back, everything is gone, and we can move again as soon as we press a button, and everything continues. So the only issue I'm still seeing here is that the score currently doesn't reset. Now we already made a function for that, so now we just gotta call it. Whenever this flap button is called again, which starts the whole process from scratch, we can just say global.emitSignal, and we can take the reset point signal. This way the score will still be visible for a while after we died, until we press the flap button again, at which point it restarts. See, now it's still visible. Now if I press the button, it goes back to 0, and everything is fine. And here we are. This is how you can make the Flappy Bird mechanics in Godot. This will be all for today. Bye!